This is number 19, which says that a water is flowing at a rate of 5 cubic meters per second into a conical tank, shown to the right, over here. So we want to find the volume of the water as a function of the water level. So we want to find V of H. That's our goal. So how do we find the volume of a cone? That is 1/3 our base times our height. And our base in this case is a circle, so it's 1/3 pi r squared times height. Well, hey look, we have an h already, we just need to get rid of this r. That's all we have to do right now. But I can't do anything more with this equation, so I have to leave it aside. I need to look at what else do I know. Well, if I think about this cone, I can think about it as a two-dimensional triangle where I'm looking at I'm looking at a diameter of 60 meters, which I can really think about as a radius of 30. And I'm thinking about radii in this instance because that's what I have. So I don't want to think about the diameter, I want to think about the radius because I need to get rid of this radius. So this radius of 30 relates directly to the height of 120, which means that the smaller radius down here by the water is going to relate to this height of the water. So I'm just going to write out that relationship. So 30 over 120 should be proportional to whatever the radius is down there by the water over the height of the water. So if I go ahead and find what r equals, I won't have to worry about it being in my equation anymore. So what I'm going to do is I'm just going to multiply by h to the other side. So 30 over 120, that's really just 1/4. And I'm going to multiply the h to the other side, so it's h over 4, and that is equal to r. And we want to substitute this in then for whatever we have r over here. So 1/3 pi h over 4 squared times h. Simplifying this down a little bit, we're going to have 1/3 pi h squared over 16 times h. Do a little bit more, we're going to have h cubed, h squared times h, times pi in the numerator, and 16 times 3 in the denominator, and that is really just 48. So the volume of the cone in terms of h is h cubed times pi over 48. So that was A. We finished A. Next, I'm going to box all this off. We want to find h as a function of the time during which the water has been flowing into the tank. So we want h of t. Okay, so h of t. Well, I don't really know anything about the height right now, but I do know something about the volume. The volume is changing at a rate of 5 cubic meters per second. So volume is changing at 5 cubic meters per second. So every second, our volume is getting bigger by 5 cubic meters. Okay. Well, let's see here. Over here, I have the volume. It's in terms of h. If I switch this volume, what I know it is actually 5t, I can then solve for h. So if I think about it like this, I can say 5t equals h cubed pi over 48. I can now solve for h, and that will be in terms of t. So I'm going to multiply the 48 to the other side. So 5 times 48 is really 240. So I have 240t equals h cubed pi. Let's divide the pi to the other side. So I have 240t over pi equals h cubed. And then lastly, let's take the cubed root of that, or raise it to the 1/3 power. So however you want to think about it, you can think about it as the cubed root of 240t over pi equals h, or you can think about it as 240t over pi to the 1/3 power equals h. But either way, we have our function h in terms of t, and that is all we were asked to find. So we are done.